So it is not very often that I do notes this way, but I'm trying to put together something that will sort of just help us walk through the pieces we need to talk about today. So today we're going to talk about causation versus correlation. And these are two of the most misunderstood terms when we are talking about data. Okay, a lot of times people like to use causation when what is happening is really only correlation. So we want to make sure we have a really solid understanding of what these two things mean. So when we are talking about causation, we are talking about a direct cause and then effect. Okay, we have enough data that will show us, we know without a doubt that one thing that is happening is causing another thing to happen. Okay, this often has to be done with very extensive research and studying. So it can't be as simple as just, oh, I just observed this happen, so it must be the case, right? So probably not something that we're just sort of picking on a whim, okay, but something that we're getting much more knowledge about. So there's been extensive research done about medications. So we can now say taking Tylenol helps a headache. We know that that's a causation because we have research that proves that. Okay, so a causation is a direct cause and effect. We have enough info or data that's showing us that without a doubt, when one thing happens, it causes another, right? I push someone, they fall. What caused them to fall? I pushed them. We directly saw it happen. We know it caused the other. A correlation is actually what is more likely to be happening in the data world. And a correlation is when two things are related to each other, but we do not have enough to show a direct cause and effect. Okay, now there's a really fancy thing that we can do in math. So we can calculate how close two things are related by getting what we call a correlation coefficient. We're going to talk about that in just a minute. Okay, but so we can tell how two things are related if they're strongly related from a correlation coefficient, but we cannot show cause and effect. And this is one of the most common ways that data is misrepresented. So I'm going to show you a couple extreme, sort of ridiculous situations. So there's a link here, but I already have it pulled up. So for example, here is some information showing per capita cheese consumption and how it correlates with the number of people who died by becoming tangled in their bed sheets. Absolutely ridiculous, right? But if we look at this data, we can see how close these two graphs are to each other. And so it might look like, right, well, when one goes up, the other is going up. And therefore, if you consume more cheese, okay, the more cheese that we're consuming, it's more likely that we will die becoming tangled in bed sheets. Clearly, right, that we hopefully can realize in our head that those two things aren't a direct cause and effect. But again, we can represent what looks like on a graph that those two things are related, even though there's no relationship really there. Okay, so there's a bunch of ridiculous things here, right? Divorce rate in Maine versus per capita consumption of margarine. Don't ask me who had enough time to go around and find these sort of things. They just did. Not sure on this one, right? This sort of just has a bunch of graphs that really closely line up. Now, I want to show you right here. You'll notice up here, there is a correlation number. You'll see this R equals, and we see a percent. That's the correlation coefficient that I was talking about. Okay, so mathematically speaking, we can calculate a correlation coefficient. Mathematically speaking, when we look at or talk about a correlation coefficient, oops, I have this dragged in the wrong spot, didn't quite move. Okay, when we talk about a correlation coefficient, it's a value that is calculated from this super complex formula over here. So you probably look at this formula and don't even know what most of those symbols are. That's fine. We are going to use technology to help us calculate the correlation coefficient. Okay, we represent it with the letter R. So just like M stands for slope, R stands for the correlation coefficient. Okay, it is always going to be a value in between -1 and 1. So the correlation coefficient cannot be larger than +1 or smaller than -1. The closer the correlation coefficient is to -1 or to +1, the stronger the relationship is. Now, with that being said, if we go back and look at these graphs, right, this graph tells us up here that our correlation coefficient is 0.947. That number is really close to 1. Right? We are almost at 1. So we are calculating a strong correlation coefficient. We are seeing graphs that line up really close to each other. Okay, but we still know in our brains that this is not a cause and effect. Okay, somehow there's some weird relationship with this data. And even though we get a really strong correlation coefficient, that doesn't mean that we know one thing causes the other. Okay, so these are obviously ridiculous situations. We do often like to say that the closer or stronger that correlation coefficient is, the more likely one might be causing the other. But we do not know anything for sure, right? And so these are sort of our ridiculous situations verifying that. Okay, so right, you can scroll through here. We'll see higher correlation coefficients, but it does not tell us anything about the actual data having one cause the other. That's the big piece you'll keep hearing me say. A correlation does not mean that it caused something. So let's look at this example. Researchers found a positive relationship between the happiness of elderly people and the number of pets they have in a study that they conducted. Okay, so in a study that they conducted, researchers found that the more pets elderly people had, okay, they seemed to be happier. So if we make the statement, having more pets causes elderly people to be happier, is that statement a causation or is that statement a correlation? So I want you to just guess from what we've learned about those terms what you think it is. Now, this situation would be a correlation. We do not have anything that will tell us with a direct cause and effect that just because you have more pets, elderly people will be happier. For example, if you have 42 cats, does that mean that you're happier, even though that might be more than 2? Okay, what if you're allergic to cats? Maybe you're not going to be happier with cats at all. What if you're just a grumpy person? Right? There are other factors in play. So maybe there's some relationship between having pets and elderly people being happy, but it is not a direct cause and effect, so we cannot say it is a causation. So here's a graph that shows how many crimes are in an area, as well as the number of coffee shops that there are, right? So we can sort of see, right, when we have maybe 15 coffee shops, we have more crimes seeming to happen. So if we make the statement, having more coffee shops will lead to more crime, would that be a causation or would that be a correlation? We should have picked correlation on this, okay? Because just because there's more coffee shops doesn't mean that there will be more crime. Now, maybe that means you live in a larger city where there are more people. More people lead to more opportunities for crimes to be committed. Okay, so while there might be a relationship there, it is not a direct cause and effect. Could we maybe look at how many coffee shops are in an area and maybe make some predictions about what the crime rate will be? Sure. Okay, but it's not going to guarantee it. It is just a correlation, not a causation. Ice melts when exposed to heat. That's a statement that we know. So the statement we're going to make is the higher the heat ice is exposed to, the higher to heat, I guess I should maybe say the higher heat, no two there, the higher heat ice is exposed to, the faster the ice will melt. Is that a causation or is that a correlation? For this one, we should have picked causation, right? What is causing the ice to melt faster? Definitely the heat. Okay, we know heat makes ice melt. The hotter it is, the faster it's going to melt. That is a direct cause and effect that we know to be true.